The Japanese government plans to release treated wastewater.
The only way, it thinks, to deal with all of the contamination.
So, Japan is going to dump its nuclear wastewater into the Pacific Ocean, and people are furious about it. What might drinking potentially radioactive water mean to me, to you, to the human race, and the entire ecosystem? This leads to another question. Is nuclear really safe? Is it helping our society to progress? Or is it actually a nightmare that one day will terminate the whole world? Just a little recap of the whole thing here.
家が津波で流されている様子がわかります。住宅や建物が津波で流されています。
In March 2011, an earthquake and tsunami hit Fukushima, triggering a full meltdown of the Fukushima Daiichi nuclear power plant. Since then, water has been used to cool the damaged reactors and filtrate the highly radioactive groundwater. The water has been kept in tanks and it's now reached over 1.3 million tons. And how much is 1.3 million tons of water exactly? An Olympic-sized swimming pool measures 50 meters by 25 meters and can hold 2.5 million liters of water, and there are 500 of them. But now Japan says it can't keep storing the water and has decided to dump it into the Pacific Ocean. But initially, when the power plant exploded, what freaked people out the most?
There was very large releases of very mobile gases.
This is Sean Burney, the senior nuclear specialist with Greenpeace, who has worked as a nuclear campaigner and coordinator since 1991 and has visited and worked in Japan for over 30 years.
One of the most serious was two particular isotopes of cesium, cesium-137 and cesium-134. And it's what you measure mostly now in the environment, in parts of Japan, in parts of Fukushima, which remain highly contaminated. And that radioactive cesium, because of its half-life,
Half-life is the length of time it takes for half of the radioactive atoms of a specific radionuclide to decay. For example, if a radionuclide has a half-life of 10 years, then 10 years later, a sample originally containing 8 grams of that radionuclide would contain only 4 grams of it and would emit only half as much radiation.
Cesium is about 30 years. Generally, you make the case about 10 half-lives is when a radioactive material remains hazardous. So in the case of cesium, it's about 300 years for cesium-137.
The radiation from cesium-137 can throw cellular machinery out of order, including the chromosomes, leading to an increased risk of cancer. Some other serious radioactive components that were documented in the total emissions include iodine-131 and cesium-134. Strontium and plutonium have also been found. We know the water that's said to be released was full of these vicious components. Japan knows it too. And when we know something's bad, we try to change it, we try to make it good, right? TEPCO has told the world that the water has and is still going through a process called Advanced Liquid Processing System, a pumping and filtration system which uses a series of chemical reactions to remove 62 radionuclides from contaminated water. But there's one thing it could never get rid of.
They're left with tritium because tritium basically just behaves as water, and it's incredibly difficult to separate tritium from huge quantities of water.
So do we have any proof right now to show that the water after the treatment, it will be 100% safe to go into the ocean?
We could never claim this is absolutely 100% safe. Almost nothing we do in our lives is absolutely 100% safe. There is radioactivity in the ocean. If what you did is added a small extra amount, it's probably not particularly harmful, but less is always better.
Out of all the articles I've read, what Professor Liven said is the most common opinion. Most people don't think it's a big problem, as long as the discharge radioactivity amount is minimized and lower than the regulatory levels. But the problem is, will it actually reach that standard? What the neighboring and Pacific Island countries have been complaining about is that Japan isn't open and transparent enough about this. And this is why there's another voice.
This is radioactive water. It is a threat wherever it is. What you don't do is you uncontrollably release that into the environment.
It's definitely a threat. I mean, we've had accidents and incidents caused by nuclear. We have so many of them, like the catastrophes like Fukushima, Chernobyl, 3 Mile Island, and they all happened in the past 44 years, right? And I think to a great extent, people's concerns and fears over nuclear power, nuclear energy come from these accidents. But after doing some research, I found out that surprisingly, nuclear kills less compared to other forms of energy production. In 2021, the world's electricity consumption reached over 25,000 terawatt hours, and 1 terawatt hour of energy can support 94,000 American homes. We're all aware that right now we still heavily depend on fossil fuels like oil and coal for electricity and power. And you don't need me to remind you that they can be super dangerous. I'm talking explosions, fires, and hazardous pollutions, etc. And that's why I want to show you this chart. It's crazy. For every terawatt hour of electricity, brown coal is responsible for almost 33 deaths. But check this out. When it comes to nuclear power, the number of deaths is almost 0. I know, I was blown away too. And despite the Fukushima explosion being incredibly destructive, no one actually died in the nuclear accident itself. What's left for us is to make sure nuclear power plants are well regulated to avoid disasters.
You can design it in such a way that you absolutely minimize the consequences of those accidents. If you look at 3 Mile Island, Chernobyl, Fukushima, it's easy to look back and see what was wrong. You just cannot make those mistakes again. So there is in some ways a more equal analysis of the costs and benefits of nuclear energy versus other forms of energy.
Right, compared to other forms of energy production, nuclear energy is more efficient in many ways, especially in terms of environmental protection. Nuclear power has a minimal carbon footprint of around 15 to 50 grams of CO2 per kilowatt hour. In comparison, the average footprint of a gas power generator is around 450, and for coal, that number is around 1050.
We just have to be very open in the way we use nuclear power. But there are risks, there are benefits, and be open about it.
You see, there are two sides to every story. On the one hand, the benefits we get from nuclear power are absolutely huge. I mean, it's a super efficient way of generating electricity, and it's much better for the environment than burning fossil fuels. On the other hand, there's a certain amount of risk. But hold on, it seems that we forgot something really important here. Why did we even start using nuclear energy in the first place? Since the Second Industrial Revolution, our demand for energy has risen a whole lot due to the increasing consumption of vehicles and air conditioners that require an enormous amount of electricity. Since the 21st century, global warming has become the one big focus of the entire world. At this point, nuclear isn't just a military weapon anymore. It has become a hotspot for solving global warming.
The next miracle, these are ors so far, is nuclear energy.
Scientifically speaking, nuclear power does seem like a pretty awesome idea. But here's the thing, we can't just rely on it to save us from the mess we've made. I mean, sure it might help in the short run, but in the long term, we need to come up with some better solutions.
So if we are serious about dealing with climate change, and that's really renewables and energy efficiency, the costs of wind and solar over the last 10, 12 years have declined by 80, 90%. So that is only going to continue.
But again, as clean as they can be, wind and solar energy are still heavily reliant on the weather. When it comes to having both clean and controllable energy, nuclear is our to-go option for now. But let's not forget, the fight against climate change requires us to push the boundaries of technology and make some tough decisions. Because in the end, what we all want is a bright and prosperous future powered by the energy that does the least harm to our beautiful Mother Earth. Keep fighting the good fight, and until next time, stay awesome.